Okay, good afternoon, and thank you for joining today's WebEx on managing interruption to water supply. My name is Stuart Paczynski, and I'm the product director for our mobile applications at AMT-SYBEX. And I thought I'd start today by introducing a couple of statistics or numbers that I think are very revealing about the importance of interruption to supply in the water industry. The first one is really a percentage which, despite significant improvement over the last 2 to 3 years, Ofwat are still targeting a significant reduction in supply during the next AMT-7 pricing period, a 64% improvement, which is a fairly significant amount. While interruption to supply, which is often caused by leakage, faults, and other disruptions, has made an improvement, the focus is still there by the regulatory commissions to vastly improve on where we are today. The next couple of numbers are really reflective on the opportunity here. And by opportunity, I'm really talking about financial, both in terms of rewards and avoiding potential penalties. And if we look at the last period, AMP6 period, the largest penalty during that period was around £16 million. And that's pretty significant. But if you then look at the largest outperformance reward that was delivered of 30 million, which is about double, the opportunity to move from being penalized for too long of interruptions or missing targets to potentially being rewarded for them has the potential to be quite significant. And if we look at the last number on the slide, just under 50% of the water utilities across the UK did not meet the performance against their targets in the last year, in the 2018 to 2019 period. So there's plenty of opportunity for growth in this particular area. What we're going to talk about today is really a solution, and I just wanted to put up a slide here at the beginning that introduces the solution that we're going to talk about a little bit later on. And this is a solution that directly targets helping water companies improve and minimize the amount of time that supply is interrupted or disrupted for its customers. It's based on a software product that we have in the market. It uses a number of tools and capabilities within the mapping solution, and it's really aimed at helping the field engineer who's out on site trying to address and fix the problem. So it's very much around enabling and mobilizing the field engineers to give them the information they need to identify those assets and those customers that are directly affected by any disruption, to isolate the problem, to trace and track and identify options in terms of how to minimize the number of customers that are affected while maximizing the speed at which a fix can be put in place. And using that data and using that information, the work can be completed more quickly, therefore reducing disruption, therefore reducing potential penalties, but also providing data and information that can be shared with customers in order to keep them informed about the status of any disruptions. So that's a snapshot of what we're going to talk about. Before we begin, I just thought, for those of you who have joined the call who are not familiar with AMT-SYBEX, just share some brief information about who we are. We are a software company, and we've been working in this industry for nearly 30 years now, and we focus on utility organizations, the water industry, as well as other energy and infrastructure organizations, providing software that enables productivity and efficiency for managing asset-intensive work. We were founded in 1990. We have offices across the UK. We're about 300 people strong, although we were acquired by Capita back in 2014, and therefore have the breadth and depth of the capita financial and employee depth and knowledge and expertise behind us as well, with quite a significant backing by a very stable organization. We've been working in this industry, as I said, for a number of years, and I've worked with 5 of the 6 big UK energy suppliers and about 50% of the electricity, gas and water utilities across the UK and Ireland. So we have quite a strong presence, a fair amount of expertise, strong references in this space, and the solution that we're going to talk about, interruption to supply, today is very much based on some proven software that we've developed and delivered to a number of our customers across the market. So our agenda today is to really spend the first part of the call talking about the need and understanding where the opportunity is. And by opportunity, I'm talking about the opportunity to minimize the disruption, to quickly shut down any interruptions to supply and get service back up and running quickly. It obviously also presents the opportunity of addressing the potential financial penalties and rewards that I mentioned earlier. And then we'll talk a bit about the solution and introduce you to what the Geofield interruption to supply solution is. And I'll walk you through a scenario showing how the solution uses its mapping and tracing tools to allow engineers to track the problems and resolve the problems quickly. As we put up on the opening slide, and if you didn't see it, we will have an opportunity for Q&A at the end. Please submit your questions throughout the presentation. We have a few of my colleagues standing by to take your questions. So use the Q&A link, the online chat, to ask your questions. This obviously is a one-way communication with me speaking to you at the moment, but the Q&A, if you submit them in writing, we will address those at the end of the call. So in terms of understanding the need and understanding where this sits within the priorities for water companies, we know there are many challenges facing the sector at the moment. And these range from everything from changing and rising customer expectations through to managing assets and making the maintenance and inspection of those assets more efficient and more productive. And doing this with the backdrop of cost cutting and managing very challenging ODI targets that have been set by the regulatory commissions, all the way through to recognizing that the environmental damage, with leakage being one of the main areas of focus for water companies, not only because it's very cost intensive, but also there's a perception that is very wasteful by customers, all the way through to our ever-changing political and social climate. And we know that there's many aspects of that are carrying on from Brexit through to the COVID-19 situation, as well as a lot of the businesses now with the emphasis on focusing on more socially responsible behavior. There's a constantly changing landscape that water companies are facing, and we as consumers as well are aware of. And the need to understand all of these moving parts and all of these challenges places the need for providing a resilient, consistent water service at the forefront, because as soon as the interruptions continue and as soon as customers are without the service that they are paying for, then that's where the challenges, of course, begin, not only from a customer expectation and reputational point of view, but also from a cost and a maintenance perspective. So we know that interruption supply is fundamental and important and critical for water companies to maintain. I've had the opportunity in preparing for this WebEx to look at a number of the annual reports and strategy documents written and produced by the water companies, and interruption of supply is front and foremost on all of them. And we know because Ofwat measures the efficiency of this and the ability to deliver against those SLAs, that it's an absolutely critical area being looked at. There are a number of initiatives on the customer expectation side. It's becoming more and more visible with the advent of social media and the ability for customers to get much more insightful information. It just raises the bar even that much more in terms of understanding how to manage and deliver in this sort of environment. Ofwat have a number of definitions that they provide in and around water interruption. There's even a formula that they use to produce the sum of the disruption over the course of a year. But fundamentally, what we're talking about here when we talk about supply interruptions and the way that Ofwat measure them is when customers are without continuous supply of water for over 3 hours. And many of the targets that I referred to earlier, each water company has a different target, as you know. And if we take an average across the industry, it's about 12 minutes on average per household across the year that's being measured in terms of how much water is flowing and what the disruption length of time actually is. So it's a pretty well understood, it's a pretty well documented area. And as I said, it's certainly measured and looked at very closely by the economic regulator, Ofwat. We know that it's critical and it's important to some of the key stakeholders, as I already mentioned. Clearly, customers have higher demand and higher expectations for a consistent quality level of service. And any time without service, it has the potential for significant social media and publicity, negative publicity for the water companies. So we know they have more choices as consumers in the variety of services that they have. They have a stronger voice. They're more sophisticated in many ways just because of the information and data that's been made available. And we know the water companies are focused on this, and as I said, it's front and foremost in many of the strategic and annual reports that are published. There's clearly the impact of large penalties and rewards, but also the risk of reputational damage for notoriously or regularly being out of service. So there's customer and operational service standards and SLAs that must be met, and the water companies are very aware of how this is positioned and how this is reported upon. Excuse me. And of course, the regulators themselves, there's a number of regulators that oversee the water industry. I've talked about Ofwat mainly because of the economic regulations that are enforced and in place for paying rewards or submitting penalties. But these regulators have a strict set of guidelines and metrics, as we know, and SLAs that are put in place for managing service and managing any interruption to that service. So we know that this is both strategically and operationally critical and important across the stakeholder spectrum. So if that's sort of a baseline for setting the standard for what the need is and where it comes from and how it's being driven, I suppose we could, the next thing to look at is quantifying the opportunity here for what it might mean and what it does mean for water companies to make improvements on the amount of time that water supply is interrupted. And as I said, many times this is planned interruptions for necessary repairs and work, but also times it's unplanned or emergency when there's burst water pipes or leakage that becomes a problem, and it may be on the follow from storms or floods that we've had and as we've seen over the last year in the UK. So we know that there's a focus on this. We know that these planned and unplanned situations happen all the time. And the opportunity here is really for the water companies to recognize how they can shorten the amount of time when it does happen, make sure that when they're planning for maintenance or service to any of the pipes or valves or assets that sit above ground or underground, that those are managed as quickly as possible and the interruption is minimized, because that will clearly influence and dictate the penalties or potential rewards that are available to them. So there are strict SLAs that are put in place. Many of the SLAs are enforced by the regulators, but of course there are self-imposed SLAs that the water companies need to meet and that they commit to their customers. And it is about delivering that better overall quality of service and introducing that. And as I said before, it's about the reputational damage that could be done, but also the positive reputational measurements that are being put in place, as well as any of the financial penalties. If we look at a number of these are actual examples. I've removed the names for the purposes of this presentation. Although this is public information, I didn't really want to take the opportunity to put specific names in here. But these are actual results from 5 companies operating in the UK, and this is basically the performance that they've reported in their annual reports in the last year, about how they performed, both in terms of the average 12 minutes that I mentioned earlier, which is the target. And again, it is on average. Each company, depending on its location, depending on its situation, depending on its geographical location, that number will be smaller or higher. And Ofwat does do a good job of working with these organizations to define a specific threshold where this is measured. But if we look at the opportunity again here, as well as the impact that underperforming might have, you can see that there's some pretty large numbers here. That just in the year 2018 to 19, Company B, for example, had an underperformance penalty of £10.5 million just in that 1 year. And if you look at that across the entire AMP6 period, they're about £16 million. Conversely, you have other companies like Company D that has continued to deliver below the threshold and have had outperformance rewards of £4 million in year, and are expected to hit nearly or over £30 million over the course of the AMP6 period. And as that moves into the AMP7 period, you can see the opportunity for further benefits and further improvement for all of these companies. So really the goals clearly are to reduce those costs and penalties from not meeting the SLAs to increase whatever revenue they might be able to achieve and turn that around. And you can see that the swing can be quite large to go from underperformance to overperformance. And of course, the opportunity for strong customer service, and you know, again, we probably know that the SYBEX measurement has come in play in the last couple of years, and this is something that is being measured again by Ofwat, and allows for comparisons and measurement around the type of customer service that's provided, not only within the industry, but there are also now metrics being put in place for comparing and measuring how organizations perform against other retail organizations. And I think that's also quite interesting, and it allows for strong comparison and an opportunity for companies to focus on improvement in those areas. Okay, so that's setting the scene. Hopefully nothing earth-shattering or there, but certainly some quantification of the opportunity and where the need sits and the priority that organizations play. I want to shift our focus now to talking a little bit about the solution that we have, which is, as I mentioned earlier, based on a solution, a map-based work and asset management application called Geofield that we've had in the market for a number of years. And this interruption to supply solution utilizes the mapping and tracing capabilities tools within Geofield to identify and link which customers and assets are affected by, in most cases, unplanned interruptions. So we're talking very much about a solution that is, I guess, reactive or post-incident, and it's enabling the field engineers, the mobile teams, to have information at their fingertips using software and mobile devices to track the information and understand what's the impact, identify quickly which assets have been affected, which customers are affected, how do we isolate that, and how do we then move to a point where we can fix the problem as quickly as possible with minimal impact across the customers. It uses standard water business processes and workflows, so it's very much been built for the water industry, and defined workflows exist within the organization to manage typical scenarios and use cases that water companies will face. And it's based on collaborative work that we've done with a few of our customers in this space, where we've taken feedback and input from them and understood their requirements and needs to help build out the solution. And so it's based on real practical data, information, and design. So effectively, what does it do? Well, as I said, it's very much focused on enabling the field engineer who's in the field, who's been called out to address an interruption to service. So the first thing it does is it allows them, while they're in the field, to identify the customers and the network assets affected by the unplanned outage. Using the mapping capabilities and using the tracing tools, they can quickly isolate and identify where the problem exists, both above ground and underground, to identify where the fix needs to take place. So it uses the tracing tools to get an accurate picture of the customers, and it allows them to immediately create a work order for them to begin the work to make the repair. So it isolates the network, or the section of the network, or the valves, or the assets, or the pipes that are in demand. It allows them to identify other potential ways of still servicing customers, and then it gives them the data and the information to then communicate back to the company how long the repair will take, and information that can then be shared with customers about whether they're affected, how long the outage will be, and so forth. So there's a number of elements in there that provides real-time data and information to the field technician in order to complete the job. So what I'd like to do is just walk you through a very straightforward example of how this works, taking some of the screens from the interruption to supply. The first thing that the field engineer will have will be a screen that allows them to identify the area where the disruption has taken place, where the interruption to supply has taken place, and identify which pipe or asset they would like to begin running a trace on. So in this case, the engineer has identified the pipe. They click on the asset on their map, and it identifies which asset is affected, and it shows you the length of the asset, or in this case, it's a pipe that runs along that road for however many meters. And the next thing that they would then do is, once they've started this trace, once they've identified the asset, they would start a trace, which would then show the different valves and the different customers that are impacted by this particular interruption on that particular pipe or piece of asset. So the information that's provided here is a visual view of the different properties and customers that are impacted, a view of the different valves that can be looked at and understood, and information for the field engineer to make decisions about running another trace or a backwards trace to identify which customers can be immediately affected or potentially supported by turning a valve on or off in a different area, and allow them to still get their water service, and further break down and isolate the point of problem. So in this case, a backfeed trace is run, And what this is showing is where other sources of water can come from, what other valves might be used, and again, the technician has the choice to open or close different valves and run different traces to find the best alternative or best solution for addressing the problem. And what this is now showing is which backwards trace opens up different valves, which customers can potentially be serviced by a different source, and then it allows you to open or close those valves and see the impact. So that initial red area here that has now been identified to a much smaller area of those immediately impacted by this, because the area, I don't know if you can, if it shows well on your screen, but the purple and I guess the brown or beige colors show that those customers that were originally impacted, actually by opening up one of the valves at the top or the bottom of this diagram, allows them to be fed by a different source, meaning that they won't be out of service and they won't be impacted. So this is giving capability to the field engineer on site in real time to make an assessment in terms of identifying and minimizing the impact on customers, and providing information and recognizing where the assets are, where to dig, where to identify the right valves, excuse me, to isolate those customers that will be immediately affected, and again try to minimize the number of customers who are affected. The results summary then really shows which customers are affected, those that will be directly isolated, those that might be indirectly, and maybe those that won't have any impact at all as a result of making a change to one or two of these valves. And by turning those on or off, the field engineer can run different scenarios and identify the one with the least impact. And by identifying the customers, it will also then pull up the information about which customers are affected. It can also then identify the orange triangles with the exclamation point here is representing those customers that are at risk or considered to be higher profile, where maybe something needs to be addressed. So if there are any customers that maybe fit the high risk category, they may need to be supplied with bottled water or whatever the scenario might be. You have that information also available as part of your database, which comes up, and therefore they can make arrangements for addressing those customers appropriately. So that's just a quick walkthrough of how an interruption of supply can be managed and the type of information that the field engineers have at their disposal to make the decisions on the ground to minimize the disruption and get the service back up and running quickly, and also to be able to communicate that information back either directly to the customers or back to base, so that communication can be provided with regards to when the service will be up and running. So as a summary, and then we'll open it up for any Q&A, and I see a number of questions have been coming in while I've been talking. I'm not reading the questions, but I do see that there's been some activity, so that's good, and we'll get to those in a minute. But really, the objective here of the interruption of supply tool or software that we provide is all around keeping the water flowing. So it is advanced technology. It's taking advantage of map data. It's taking advantage of sophisticated tracing tools and a recognition that we have information at our disposal that can be used to help get services back up and running quickly, whether they're burst water mains, whether there's just evidence of ongoing leakage or faults. The engineers have the opportunity to correct that information in the shortest time possible. It is a dedicated module of our software that is made available, and it has been designed specifically with the water industry in mind. So we do have, as I mentioned, the dedicated water workflows and use cases and a data model that supports this particular industry, and it allows the engineers to have that information readily available. And hopefully the long and short of this is, by getting services up and running more quickly, by improving and decreasing the amount of time service is out, that if you're currently getting penalties, or even if you're getting some rewards, you're able to increase the amount of rewards you get by staying well under the threshold for being out of service. Okay, that's all I had in terms of a formal presentation. As I said, we're very happy to take the questions and answers. There's some information here as well if you want to get in touch for a further conversation, perhaps a further demonstration or a more detailed conversation. There's information here about how to get in touch. So at this time, I'll maybe hand over to my colleague James Palmer, who's been monitoring the questions, and see if there's anything that we want to take on board.
Thanks, Stuart. Yeah, we've got a question here around can customer agents have access to what the field engineers are doing, so to act as a real-time source of information to update customers?
So yes, the information is shared dynamically with the customer agents, and the information that the field engineers see on the map information can be communicated back to the agents, so they will have the most up-to-date information about the outage and the repair times, for that matter.
Got another question here. Are there any analytics packages to work with this for reporting purposes, or is there integration to other back-end dashboard systems possible?
So I'm gonna answer part of that, and then I know some of my colleagues are on the call, and I may hand over to my colleague Richard to add any further commentary. But as part of the Geofield package, there is a back end to the solution that provides analytics and reporting capabilities, and the interruption to supply data that's collected and shared will be processed and can be provided back to that. Of course, we also have the ability to integrate with other BI tools, whether it's Power BI or some other tool that maybe a water company uses, and the data that's collected from any work that we do can be shared with external analytics and reporting tools. But Richard, I don't know if you want to add anything else to that.
No, there's nothing really to add to that. The data is accessible at the back end and could be consumed by any reporting warehouse.
Okay.
I think that's it for now. Okay.
If anybody has any further questions, maybe drop them in the next 30 seconds to a minute. Otherwise, again, there's our contact information at the bottom of the screen here. Please do get in touch if you'd like some more information about this particular solution. We'd be very happy to speak to you further.